Hi, we are going to be doing a video today about tangents. So this is a newer topic. This is something you would not have learned in grade school or junior high. Tangents is something that they reserve for high school and college level geometry classes. So we are going to be talking about all different kinds of little facts and tidbits about tangents. And maybe learn a couple tricks while we're on their way. Okay, so here's a review. A tangent, in the past, we might have said a tangent is a line that is touching a circle in exactly one place. So that is considered a tangent line. But there could be other uses of the word tangent. So you could have two shapes that are tangent, two objects, if you will. So a circle and a square could be tangent in one spot as well, for example. There's a lot of options here. So that's what the notes are about. So we're going to be looking at Unit 8 circles, Day 3 tangents on circles notes today. You can download this. I notice I did not erase everything completely. And just get to it. Concentric circles are not tangent lines. This is just a weird tidbit that doesn't fit in anywhere else in our notes, but it is something that's worth talking about. Concentric circles have the same center. But different radiuses, okay? So when you have a different radii, if you will, you could have your eyeball, you could have your targets, all kinds of different wheels, all kinds of things where you have the same center. A center is pretty important for a circle. It identifies, for example, like the center of gravity, if you will, if it's an equally weighted object. The axis would go up through the center like a record, if you guys are using the old the vinyl, okay? But that is something that it's going to come up every now and then. They're going to talk about this word concentric. So I just want you to be aware of it because it will come up later, okay? So let's get into tangents. Let's talk about circles that are tangent. You could have circles like on the left where they are externally tangent, okay, externally tangent, or you could have circles on the right where they're on top of each other, but they're still, the outer edges of the circles only touch in one spot. So this single point for each one of those is still true. They are tangent. If you only think about the line of the circle, they are externally or internally tangent to each other. So now let's think about the word external and internal. If you have something inside of you, it would be internally, okay? Or if it's something outside of you, it'd be externally, okay? So if you have a cut on your skin, that'd be external. If you have a bruise under your skin, that would be internal, okay? So externally tangent, they're not on top of each other. They're outside of each other, outside. Internal is inside. Now, the reason why I'm making a big deal out of this is everybody's going to get the fact that they're tangent, but they're going to screw up the word external and internal. So make sure you learn those words and understand what they mean. Because if I just give you a picture and I say, hey, are these externally tangent or internally tangent? It should not be a 50-50 guess. You should actually know what those words mean. All right, let's talk about tangents. So tangents, I thought this was a really cool picture. If you think about like a hanging basket, here's the basket right here, okay? If I was to put a string on the edge of this basket and I put another string on the edge of this basket, those are tangent strings to this basket, okay? So it's a way to hang things. Looking at this, it almost does it. You have to imagine, I don't like the blue, let me do a brighter color here. If I was to draw this road really thick, there's your circle tangent to the road. That's what you're supposed to see there, okay? I thought that was a nice picture as well. A bunch of circles that are tangent. In general, a basketball or any ball sitting on a table or a ground or something like that is only touching the ground in one spot. So that ball is tangent to the ground. This wheel, if it's a very well inflated wheel, is also tangent to the ground, okay? Here is some chains on a bicycle. Notice this line here, if I was to extend this line outward, it is tangent to both of these circles, okay? They touch in one spot. I know it wraps around, but if he was to go straight forever, those would all be examples of tangents that are around all over the place. So let's talk about lines that are touching or involved with two circles. So you could have common tangents, meaning I've got that gear that we showed earlier, and I've got a chain that goes and touches both gears at the same time. Well, that's a common tangent. A common tangent. Common tangent. But we can be more descriptive than that. We can have common internal tangents and common, oh my gosh, internal and external again. Common internal tangents and common external tangents. So let me zoom into these two pictures here. Consider the space in between the two circles as the interior of this picture. And consider the space outside the two circles as the exterior. So we've got the interior and the exterior. So the interior and the exterior. So looking at that, this line that is on the top picture, that line is interior. It's a common interior tangent. Common interior tangent. Okay? Whereas this one, this line here, if you're not looking at the right, this one right there, that one is touching on the outer edge of the two circles. It's not crossing in between the two circles. That would be common exterior tangent. Common exterior tangent. And I don't know why I'm writing these words since they're right there on the left. So common internal tangent, common external tangent. You need to know the difference between the two of those. So let's talk about some theorems. These are going to be pretty quick here. You can read the words on your own. Let me just use my own words to describe these. If you've got a tangent of a circle, then the radius QP is perpendicular to the line K. All right, so a tangent is perpendicular to a radius in a circle. So in the way the radius works is it's the radius that actually touches at the same point as the tangent. It's perpendicular automatically. Okay, that's sort of nice. So you can also go the other way. So let's say you see a line and it's perpendicular to a radius. And it seems like it might be touching in one spot, but we haven't really zoomed in to it like 1,000%. So we don't really know, but it looks like it could be tangent, and we know it's perpendicular. Well, then it is. Then K is a tangent. Okay, so this is actually a way to make sure you have a tangent on a circle, is to make sure it is perpendicular. There is the added bonus to this, because math teachers like to ruin everything. That's a right triangle. So we can actually do right triangle math that we did a whole chapter about on these kinds of circles as a result of tangents being perpendicular. Okay? So in a nutshell, let's just do this. If you got a circle and you got a radius and it goes to a point, and you want to draw a line and make sure it's tangent, you got to make sure it's 90 degrees. So if you have this, it's got to be perpendicular, touch the radius, and there's got to be a tangent. Those all sort of go together, okay? Those all sort of go together. All right, so let's look at this problem, this down here. Here's the different theorem. This is sort of interesting. Think about the hanging basket and the strings. So you've got this hanging basket, and you attach a string here and you attach a string here. If you do it at the same height on that basket, those two strings will be the same length, which is sort of interesting. So if you have two tangents that meet at a point, okay, they're both tangent to the circle, then they are equal. SR is congruent to SP. Okay, that's a really nice added. It's almost like an isosceles triangle. I know it's not a triangle, but it's almost like one. You could just connect the dots there if you wanted to. All right, so that is an important theorem. This one we can definitely do some math with. So we could say, for example, this is 3x, and this is 9. We could ask you to solve for x, for example. So let's do that. Here you got two examples of problems. First problem, they want to say, is this a tangent? Okay, is this a tangent? Well, if it's a tangent, I just got done telling you a couple theorems, then this angle here, this has to be 90 degrees. Or is it? That's the question. So what you're going to be expected to do in this situation is test to see if that's 90 degrees. All right, so hopefully some of you have figured out what you're going to do. You're going to use Pythagorean theorem. So looking at this, if this whole length is 17, that's an 8 and that's a 15, then 17 squared should equal 8 squared and 15 squared because this is a right triangle rule. Pythagorean theorem is a right triangle rule. This should only work if it's a right triangle. So if this is 289, this is 64, this is 225. The question is, does 64 plus 225 equal 289? It does. So yes. Okay, it is a tangent. EF is tangent. So the answer is yes. On this problem, you've got two tangents. They are meeting, and I just got done telling you this theorem. These two lengths are the same. So you should set up an equation where they are equal to each other. So you have the two tangents equal to each other, then you just have to solve the algebra. So this is just a review from last year for you, and you get x equals 5, and that would be your final answer for that one. That's it. I hope you enjoyed the lesson, and have a good rest of your day.